This video will show you how to do a transformation when your residuals from a linear regression are not normally distributed. This is a regression made of made-up data. My dependent variable is student success. My independent variables are SES, socioeconomic status, and hours of homework. As I've shown you in previous videos, I have made a residual plot. I do not see any smiles or frowns, so I assume I have linearity. But the histogram of the residuals is very right skewed. It has a very right tail, long right tail, and is not symmetric. Nevertheless, because of my large sample size of 620, I can count on the central limit theorem to cause my residuals to be normal where it counts, which is in the parameter estimations. In other words, I do not need to do anything when I have a large sample size, even if my residuals look like this. Let's take another example. When I do not have a large sample size, and discuss what we do then. In this case, I have a small sample size. My dependent variable is happiness. My independent variable is TV watching in minutes and an SES scale. Let's go to Analyze, Regression, Linear. Happiness will be the dependent variable. TV watching and SES will be the independent variables. I'll go to Plots. I will put the z-pred in the x-axis, the z-resid in the y-axis, and request the histogram of the residuals. Let's paste the syntax and run. Find my output. The residual plot still has no reasons for me to be concerned about a lack of linearity. But the residual plot isn't as normal as I would like. It looks like I have two spikes. Looks like my tail is still a little heavy. And notice my sample size of 20 people. This is considered a small sample. Anything under 30 is considered a small sample in this class. So one possible transformation I could do is a square root transformation on the dependent variable. I have shown you in a previous video that another appropriate transformation is the log of the dependent variable, and that's true as well. But the square root is another common transformation you can try. And so let's try it in this case. I'll go to Transform. I'll go to Compute Variable. I'll call my new variable, called square root, SQRT underscore happiness. And the numeric expression will be SQRT, open parentheses, drag happiness over, close parentheses, go into Type and Label. So I'm going to take the square root of my dependent variable. Click on Type and Label, click on Use Expression as Label, click Continue, click Paste. Find my syntax, run the new syntax. Bring this up and so you can see me pushing the green arrow. In my data set, I have a new variable called the square root of happiness. The square root of 24 is about 5. So it looks like it's performing well. I will rerun my linear regression with my new dependent variable. So instead of happiness, I will put the square root of happiness. Paste. Find my syntax. Run the new regression. Hit the green arrow. My residual plot still looks the same, so no concerns about lack of linearity. But the residual plot looks a lot better, a lot more normal. The two peaks are closer together, And there doesn't seem to be a long tail. Therefore, as a recap, if you have a small sample size, a transformation may be necessary on your dependent or independent variables to resolve a lack of normality in your histogram of your residuals. If the sample size is large, it is not necessary to do the transformation.